Hello all, my name is Karthik. Welcome back to the series Object-Oriented Design Patterns. In this particular video, I'll walk you through Singleton Pattern and its implementation. What is a Singleton Pattern? A Singleton Pattern is a creational pattern. That means a pattern used at object creations, and a Singleton Pattern ensures a class has only one instance at any point of runtime. Let's see what does that mean. Consider this as one of your class, and whenever you try to initialize it, an object is created in your physical memory. This object will have its state and behaviors holding with it. When you trigger the initialization of the class from multiple parts of your code base, that will add more objects to the memory. This is where singleton pattern comes in. So the singleton pattern always makes sure that no matter how many times the class is triggered, you will always end up with the same single object in the memory. Now let's look at a scenario where we can use singleton pattern. We have three classes. One is car, another one is bike, and SQLDB. Look at the SQLDB class, where I have a DB connection in the constructor and write method which will write the data into the database. Similarly, we have other two classes. One is car, another one is bike. Both of them has a constructor and a write data method inside it. We have all the three entities. Now we have a main method which is the orchestrator of our system. The main method has been called and started executing. The interpreter will start at first line of the main method. In the first line, the car class has been initialized and an instance is created in the physical memory. The car class has another initialization of SQLDB, so a SQLDB instance has been created in the physical memory. Now, if we go on in the SQLDB constructor, we have a DB connection. So, a physical connection has been established in the object with the database. Once the connection is established, the interpreter will start moving to the next line. Similar to car, the bike has also been initialized and an instance is created in the memory. And then at the end we have a database connection established between the SQLDB object and the database. The interpreter will start moving to the next line where we use the car object and write the data into the database. In this particular line, the car object will use the SQLDB instance which is created by the car object, I mean the blue one, to write the database. Once the write is done, either it is failed or successful, the status will be returned to the object and it is returned to the car object, and then it will comes to main method. Similarly, the interpreter will go to the next line. Similar to the car object, the bike object will write the bike data through write data method with the help of a SQLDB instance created by the bike object, I mean the green one. Now, what is the real problem in this design? The problem is, why do we need two separate objects in the memory to do the same task of writing into the database or any operations related to the database? Why can't bike object can use the SQLDB instance which is created by car object and write into the database? So these kind of situations can be handled by singleton pattern. I hope you got a clear idea why we need a singleton pattern in this kind of situations. Let's look at the implementation of singleton pattern on SQLDB class, because this is the class we need to have only a single instance in our memory. Take a look at the methods in the class. Those look very interesting. The constructor of the class has an access modifier is set to private. That means no one outside of SQLDB class can call this constructor. Then, how are we going to create an instance if no one can be able to trigger the constructor? Let's see the another method, getInstance. This method is checking if we have an unique instance, the variable. If not, go trigger the constructor and generate an instance for me and store it in unique instance variable. So, whenever next time you try to call the getInstance method, since we have already have an instance of SQLDB stored in unique instance variable, it will just return it. This is how we are going to get the instance of SQLDB without triggering the constructor from outside of the scope of SQLDB class, and we will always making sure that we will have only a single instance no matter how many times we call the getInstance method. Let's look at the implementation in Python because Python doesn't support access modifiers for the constructors. So the implementation is a pretty different from Java and Python. In Python, methods with prefix and suffix of double underscore are called dunder methods. Let me give you a small intro or a backstory what happens when you try to create an instance for a class. Whenever you create an object in Python, the new method runs first to create the instance and then init method runs to initialize it. So there are two methods which are running under the hood at the time of instance creation. Let's look at the walkthrough, then you will get more idea. There is a trigger to create an instance. This is when the new method gets triggered since the variable underscore instance is still none. It goes into the next statement. It goes inside the if block. The statement here super dot underscore underscore new is like it is calling parents new, but we don't have a parent for SQLDB. Who is the parent then? Every class is a child of object class in Python. This is like a global parent for every class in Python. The new method in the object class, the global parent class, is responsible for allocating memory for the new SQLDB instance. This creates a blank instance of SQLDB which does not have any state or behavior, and this instance is stored in underscore instance variable. After new method, the flow continues and trigger the underscore underscore init method where the control checks for underscore initialized variable is set to true or not. As this is the first run, the initialization has not yet happened before. The control start executing the remaining statements in the init method and add all the necessary states, all the class variables to the instance. This is where the physical database connection has been established. So this is the first run of SQLDB instance. If we go on, we try to trigger the second run. We want to create any other second instance for the SQLDB. The first, it will trigger the new method. Since the class instance is already there, it will just return the class instance. So there is no another instance will be created in the memory. Similarly, it will move on to the init method. Since the class is initialized already, it will not be initialized again. It will just return from init method. To conclude, we are making sure that no two objects are created for SQLDB by any way, either by using new or init, and we are making sure not to initialize the object, not to set the state DB connection multiple times to the object. This is how we maintain a single instance in Python. Cool, everything looks good so far. Is there any failure scenario in this? Really, the code is solid. By looking at the implementation, we are taking care of init and new methods explicitly. Let's look at a scenario. This is our code base for SQL DB. Now, think of this in a multi-threaded application. That means many threads can run the same piece of code at any single point of time. Thread A is running and got triggered for the SQL DB instance. And first it will run through the new method where it will check for underscore instance and it will be none. Since the if statement is true, we go inside the if statement block and try to create a SQL DB instance in the memory. If you observe closely, there are two things happening in the single piece of line. One, creating an object, and two, we are assigning that object to underscore instance variable. Assume that thread A is at creating object A. This is the time when thread B got triggered and slowly sneaks in to the new method and checks for the class underscore instance variable. It is still none because it is not assigned to anything by thread A because the thread A is still at creating. It is not passed, it has not passed to assigning stage. So since the if statement is true, thread B also go inside the if statement and try to create a new SQL DB instance. Now thread A has completed the creation of the object and it will assign the object to underscore instance variable. Now the underscore instance variable has moved from none to an object of SQL DB. Thread B also completed the creation of the object. It has also created a new instance of SQL DB. This time the class underscore instance will be overwritten by thread B with the object which it has been created. If you see closely, thread A has created an object, thread B also creating an object. This is a clear-cut violation of Singleton pattern. The same thing will happen with the init method. Suppose thread A is at the stage of making connection to the database. It is it is a bit resource intensive task. That means it will take some time. In the meantime, thread B sneaks into init method and try to check the condition. The condition with self underscore initialized. Since the thread A is still a database connection, the initialized variable has not set to true yet by thread A. Underscore initialized is still false. Thread B will check this condition and it will not run the if statement. Thread B will try to establish the database connection again. It's like creating the object twice in new method and initializing the object twice in init method. This is a clear-cut violation of Singleton pattern. How can we solve this problem? This is one of the very common problem in concurrency or multi-threaded application. Let's see how can we solve this problem. We can solve this problem by pessimistic locking. Let me walk through what will this do. We are going to add locks to some parts of our code base to make sure no two threads will be executing the same piece of code at the single point of time. That means all the statements in that context will be merged into one and this will be like a single statement. So one thread will run all of these statements at a single point of time. These are two locks we added to our code base, so they'll make sure all the threads will wait when a thread is in the context and running. Thread 1, thread 2 and thread 3 will keep waiting until thread 0 completes its execution. Once the execution of thread 0 completed, then the lock will allow another thread to pass through it and start its execution. You can think of a lock is a gatekeeper that will allow one thread to pass through it at any single point of time. This will solve our problem with multi-threads creating same object and initializing the same object multiple times. Well, To talk more on locking, there are two types of locking. One is pessimistic locking and another one is optimistic locking. There are some trade-offs with pessimistic locking as it slows down your application a bit because all threads are waiting at the lock, and this is one of the important concept for handling multi-threading applications. So I'm not going deep into this as this is fine for this video because this video is about singleton pattern. Where can you use a singleton pattern? What are the use cases of it? Well, DB connections and system registry configs, logging systems, or cache managers. These are some of the go-to entities where you can use singleton pattern. Always think in a particular situation when multiple instances are not required or having multiple instances can break my system or logic. Then that is the point where you should use singleton pattern. With this, we have reached the end of the video. I hope you have enjoyed the video and you learned something new. Feel free to add comments about anything, even it's a silly joke, no problem. You can add the comment and feel free to write anything you like about the video or dislike about the video. I'll see you in the next video. Until then, bye.